Hey everybody, hey YouTube, how's everybody doing? Welcome to problem 3 out of 25 for our Power 25 series. This is the 25 most essential foundational questions so you can ace your technical interviews and kind of get those kind of awesome jobs at big tech companies. So without further ado, let's get started. So this problem is called valid parentheses. So given a string S containing just the characters, we have these kind of brackets. So we have a parenthesis, a squiggly bracket, and a square bracket. Determine if the string is valid. Okay, so a string is valid if open brackets must be closed by the same type of brackets, okay? And open brackets must be closed in the correct order. So what do we mean by this? Well, example 1, we have these two, and this is fine. These are kind of balanced brackets because they're both parentheses, and they're kind of the opening parenthesis is getting closed by a parenthesis. Example 2, this is also fine because the parentheses are getting closed, the squares are getting closed, and the squigglies are getting closed. This is actually false because the parenthesis is getting closed by a square. That's not going to match. This is actually also false because in the middle here, you can see here that the square is getting closed by a parenthesis. That's not supposed to happen. And the parenthesis is getting closed by a square. That's not supposed to happen. This is actually interesting. This is true because the square is getting closed by the square and the parenthesis is getting closed by the, the squiggly is getting closed by the squiggly. So you're thinking, okay, this is a little bit hard. How are we going to kind of go about this? What kind of method are we going to use to kind of do this and keep track of all these? Well, this is actually a kind of custom example I made here. And you can actually see that looking at this is actually true because these ones close and then kind of these close, right? And then these bigger ones close. So you're thinking, okay, this is a little hard. How are we going to navigate through all of this? Well, we kind of need to realize that we need to observe this one thing. And if we have an opening bracket, you see how that these are all opening brackets? We can't rule the string out yet, right? So like, for example, if the string kind of started with the closing bracket, there's nothing to open that bracket. So it would automatically be false. But if we keep having opening brackets, let's say that we keep having kind of opening strings and our pointer is here, well, we can't rule the string out yet, right? Because there might be other closing brackets that will close these strings. So how are we going to keep track of our kind of last seen opening bracket? What data structure can we use? Well, we can actually use a stack. So a stack is just an amazing fundamental data structure that we can use here. So you're thinking, first off, what is this hash table? What is this hash table even kind of used for? Like, what is the deal with this? Well, the thing about the hash table is it's a very convenient kind of key value mapping pairs to kind of go about this. So the sort of our our kind of key mapping pairs, so our parentheses and our squares and our squigglies are kind of mapped together. And we can see how this is in the code implementation. So what do I mean by using a stack? So a stack is basically saying, if I append all of these to the stack, so I append this guy, this guy, this guy, this, and this, I only have access to the last element, which is actually really good because if our pointer is here, as long as we have an open bracket, we can keep appending to the stack. And once we find the closed bracket, we just pop this element here and say, okay, does this match? Oh yeah, it does. Same exact thing. We're going to pop this guy, right? So then we move our pointer. We're going to say, okay, we're going to pop this guy here, and we're going to say, okay, well, does this match with this pointer? Oh yeah, it does. So then we're going to do that. We're going to keep, and you can kind of see how we're moving our pointer. Now we're going to pop this guy. Oh, hey, does this match? Yeah, it does. And we're going to keep moving on until our stack is either empty or like, right, like let's say that we have this case right here, and then we append this to the stack, and we kind of compare it. So we pop this. Well, these aren't equal, right? We can check the hash table mapping. This thing here is the key, and this maps to this. Well, if we check sort of our hash table for the mapping, this is not going to be present, hence this will be false. And we can kind of keep going until our length of stack is equal to the 0. And we just have to compare one last thing, right? So if we're at the very end, our length, in this case, that's awesome. Our length of stack is equal to 0, we can return true because everything was accounted for, everything was valid. Well, if there's like a case where we have 3, let's say we have 3 and then we only have 2, well, our length of stack is actually, right, these are going to kind of account for each other. These are going to count for each other, but we still have one thing in the stack. So the length of stack here is just going to be equal to 1, and then we would kind of return true, right? Or we return false. So that's bad. So we just need to check if the length of stack is kind of equal to 0. And yeah, this is actually running an O of n time complexity. This is a very awesome and intuitive kind of solution to this. And without further ado, we can kind of go into the coding implementation, how we would solve this. So first off, we're going to initialize a stack. This is actually natively an array in Python. we're just going to say our hash table is going to be equal to, well, it's going to be a kind of array of key value pairs. So this key, a hash table, and it's going to have key value pairs. So this is going to be a squiggly. This guy is going to be a parentheses, and then this guy is going to be a square bracket, just to kind of show the mapping. And you're saying, and I can kind of go by that later. So now we can actually define a string called opening, and we can establish this to all of our 3 kind of native values. And you'll kind of see more of why this would get used. This is going to be in our closing. These are all in our closing. Okay. So now all we have to do is just iterate through the length of our string. And we can say, okay, well, if the length of stack is equal to 0 and s of I is in closing, so what does that mean? So this is the case where we don't have any opening brackets, and basically it's the case of, let's say we start out with the closing bracket. Well, we can't open these closing brackets. There's no way that we can open them, right? Because after, there's only going to be after iterations. There's no way we can open these closing brackets. Also conversely, let's say that we have this stack thing and then it closes, and there's also another closing bracket here, right? And then there's a bunch more calculations. There's no way to open that closing bracket. So in that case, we're just going to return false. Okay, well, also, well, if s of I is an opening, right, we're only appending stack values to the opening. So we're just going to append the s of I to the stack. And else, well, if else is the case of where we had these closing brackets, right? So sort of where we found a closing bracket, and let's say this is a squiggly, and we found the squiggly. This is where we make our comparison and our sort of our check marks, right? And every time that I call the hash table of our hash table of our, so what are we calling? We're calling the hash table of stack.pop, right? Remember, stack.pop pops the last thing from the stack, and it gives us our most kind of recent element. So if that's not equal, right? So if we're checking these mappings, if the mapping is not equal, like let's say that our closing bracket was a square, that's not good, right? Well, if it's not equal to that when we pop it, we're gonna return false. Else we would still pop it, right? If this case doesn't run, remember, we're still popping the thing. So we're just gonna return false, and everything is gonna get popped. And if everything kind of checks out and everything is good, the length of our stack should be 0, right? And we just have to return the length of stack is equal to 0. And if it's not equal to 0, that means that there's still preceding opening elements that weren't accounted for, hence this would actually become false. So let's go ahead and submit. And let's see this. We got a bit of an invalid syntax here. So I just made a quick error here. The error was actually, this needs to be a colon, and we're gonna try this again. And like that, we got accepted, 100% space complexity. We have a very pretty good time for our stack. And this is kind of a very fundamental kind of way of thinking, kind of to address other problems. And that's it, guys. Thank you so much for watching, and have a great day.